Okay, so 3.4. 3.4 is about graphing polynomials. We're going to do most of the graphing part tomorrow. We're just going to talk about a little bit about the graphs. Some stuff we kind of already know. So 3.4 is graphing polynomial functions. So polynomial functions are functions that have integer exponents. They're a smooth, continuous curve. The turning points are those relative minimum and maximums. So what this says is that if you have a polynomial function of degree n, then you can have at most n minus 1 turning points. So if you have a fourth degree polynomial, so a quartic, then at most you can have 3 turning points, 3 relative minimum and maximums. Then number 2 here is the converse. So if you're given a graph and you see 2 turning points, then you know it has a degree of at least 3. So if it has 2 turning points, it's a degree of at least 3. So if I look at these graphs, I want to determine which ones are polynomial functions. So smooth and continuous. So this one is not continuous because there's a break here. Continuous means that you don't pick up your pencil or pen at all. You can do the whole graph without lifting your pen or pencil. Smooth means that these turning points are rounded. So if you have a point, like that's called a cusp, if you have a point like this, like absolute value, that is not a polynomial function. Absolute value functions are functions, just not polynomial functions. So this one, A, is a polynomial function. B and C are not.
So why is C not?
Because it's not smooth. So if you have to go down at a point like this, it's called a cusp, and that is not smooth. That's not a polynomial. So your turning points are rounded like this.
Mrs. Cecil?
Yes?
Hi, could we have Maya Moment to the Counseling Center for just a moment, please?
Yes?
Thank you so much.
You warm? about end behavior. And we've talked about this already, but we'll do it a little bit more formally. So just to do that, we're going to start describing the names. So these polynomials are in standard form. Standard form, when you're writing it out, they always start with A, and then it's just however many letters you need. So x cubed is called a cubic, it's degree 3. X to the 4th, that's a quartic, it's degree 4. And then once you get past that, we'll just say polynomial of higher degree. So like this x to the 5th, it's a polynomial of 5th degree. So this is just when we write them out, we start with A and we then go to as many letters as we need. Okay, so now we're going to just look at a few graphs, and these are just really quick sketches. Okay, so don't spend a lot of time, because really more what we're looking at is just the end behavior. So x squared, you know, this is just your basic parabola. X cubed, this is the parent function of a cubic. So x squared is an even degree. And so the end behavior, the two tails are up, up. X cubed is odd. So the two tails go down, up. So this third one here, this is a cubic as well. So it's odd degree. And the two tails still go down, up. So even though there's this stuff in the middle, the tails don't change. The end behavior doesn't change. So this here is what changes the middle part here. So this is what gives me these this little wiggle here. There's two turning points. So degree 3 can have at most 2 turning points. It can have less, but it can have at most 2 turning points. Okay. So this third one is still a cubic. But that 5x plus 1 is what gives these changes to the middle part. So then if I look at these three, so the parent function of a quartic, the x to the 4th, looks a lot like a quadratic? Same general shape. This is even, and the end behavior is up, up. If I look at the next one, this second h of x here, it's x to the fourth, so how many turning points could I have? 3, so there, and that's what I have, 3 turning points. So that's the most I could have, but I could have less. This one only has 1.
When you're looking at the degree, do you add the 4 and then 2?
No, it's just of the leading term. Yep, so the degree is just 4. But the tails still are in the same place, up, up. And then if you look at x to the 5th, the parent function looks a lot like a cubic. But if you add things, then you could have changes to the middle. So a x to the 5th polynomial could have how many turning points? It could have up to 4. Okay. So we're going to summarize all of this and write out some rules of our end behavior. So for a polynomial function, we have this ax to the n. That's the dominant term. So that's where we get the leading coefficient. It's also where we get the degree. So when a is greater than 0, when the leading coefficient is positive, then it follows the behavior of the parent function. If it's negative, so it's less than 0, it will be flipped over the x-axis, so it will be the opposite. If the degree is even, then the tails are together, so in the same direction. That's either up, up, or down, down. If n is odd, if the degree is odd, then they're split, they're opposite. So down, up, or up, down. I'm going to describe the end behavior. So two things I look at. I look at a and n. So I look at the leading coefficient and the degree. So a, the leading coefficient, I care about being positive or negative. Is the leading coefficient positive or negative? Positive. If the leading coefficient is 2. So 2x to the 4th is that dominant term, so that's where I'm looking. And then the degree, I care about being even or odd. So the degree is that even or odd? Even. Okay. So then, since it's even, the tails are in the same direction, and positive means that my end behavior would be up, up. Okay. So let's write that now more formally. So last chapter, we just had to write up, up, down, down. Now we're going to write it a little bit more formally. And you've done this before in Algebra 2 and Pre-Calc. Okay, so we always do it left to right. So describing left and right. So if you want the left side, you're saying as x goes to negative infinity. And the right side is as x goes to positive infinity. I'm going to put that plus there just to emphasize positive. Okay. And then we talk about y, so f of x. These arrows mean goes to. Okay. So every time you write this, it always starts out like this. And then you fill in the blanks with your end behavior. So with the up, up, down, down. But we'll write, instead of up, up, we'll use infinity. But they always start off like this. This top one describes the left side. The bottom one describes the right side. Okay, so since it's up, up, I'm going to use positive infinity and positive infinity. Okay? Questions about that? All right, let's do another example like this. So what we need to notice first is this is not in standard form. Okay, so I need to rearrange it. So what should my dominant term be? What's the leading term? Good. You want your exponents to always go from greatest to least. Okay, then 7t to the 5th, and then, okay, and then minus 14. So my dominant term is 16t to the 8th. So the degree is even or odd? Even. The leading coefficient, positive or negative? So my end behavior, again, is up, up. And now let's write that out. So this will be the same as the last example. So start off with negative infinity. That's describing the left side, and then positive infinity describes the right side. So up, up would be, what would I fill in here? Positive infinity and positive infinity. If you have down, it's going to be negative infinity. Questions about that? Okay, so we've done this before. We've talked about end behavior a lot. Now we have specific rules and a more formal way to write it. Okay, we're going to do a practice problem. So we're going to finish 3.4, do more of the graphing on 3.4 tomorrow. But for today, I want to do one more practice finding zeros like you did on the warm-up today. Okay, so just in your notes, I would have you do it on the whiteboard. I just don't think there's a lot of room. So in your notes, I want you to find all the zeros . going to write the answers down just in case we don't have time to finish. I would like you to finish it sometime today so you practice this. Okay? So they do not need to be in that specific order.